about parts of homeostatic mechanism and how they function with one another. But first, what is homeostasis? Homeostasis is when the body is at an equilibrium. And why is it important? It's important because the body best functions when it is at that equilibrium. Let's say your body's too cold or too hot. If it's too cold, you'll notice that you begin to shiver. If it's too hot, you notice that you begin to sweat. This sweating and this shivering is your body bringing it back to homeostasis because you want to be at that just right temperature. And how does your body know that how to bring it back to homeostasis? Or how does your body even know that it's no longer at homeostasis? Well, that is thanks to the homeostatic mechanism, first part of which is the receptor, which detects any change and provides information about the stimuli. The receptor will typically consist of the sensory nerves. With that information, they're able to alert the next part, which is the control center, which is a structure that interprets the input from the receptor. This is the decision maker that contains the set point. They'll initiate the change through the effector. And a note here is that generally a portion of the nervous system can serve as the control center. The control center, going back to our example, being too hot or too cold, they know that you're supposed to be at 98.6 degrees. That is your equilibrium. That is your homeostasis. And so with that information, they're able to let the effectors know. And the effectors, here is the muscle or gland that responds to the control center and causes change to alter the stimulus. Note here is that most body structures can serve as effectors. Going back to our example, here you'll see the sweating, which will help you cool down, or the shivering will bring that body temperature in, both of which will bring you closer to that 98.6, closer to your homeostasis. Another thing to talk about are the positive and negative feedback loops. The example I gave earlier was a negative feedback loop, which decreases or lowers the changes and will move the system towards its equilibrium, which is the most common between the two. The example here again is body temperature. And for positive feedback, the most uncommon between the two, will amplify or increase changes and will move the system away from its equilibrium. A very common example for this one is childbirth. And that is homeostasis, but it just keeps going. It is a cycle that is never ending because naturally, well, ideally you want to be at homeostasis, you want to have that balance, but naturally your environment will just cause you to create a small imbalance, and it's okay because the cycle will just start up again. The receptor will automatically know and will let the control center know, which will decide what to do, where it's supposed to be, and the effector will actively bring you back to that homeostasis. Thank you.